Alright, so in this video, we will see how to use the 8C12 serial transmitter and receiver module so that we can use it with the APM 2.8 flight controller and use our computer as a ground station to control the quad. Now, ideally, you would use the 3DR telemetry kit that you get for the APM flight controller. But since it's not available anymore and it's very expensive, I figured that the 8C12 is a perfect alternative. And there are a couple of reasons for that. Firstly, this 8C12 is a 433 MHz transmitter and receiver module, and the maximum power output is 100 milliwatt. And the claimed range as per the specifications is about 1 kilometer with the spring antenna. And because I have a fly sky receiver on this, I obviously don't plan to fly beyond 500 meters. So the range of this 8C12 module for the telemetry is perfect, and it seems to be perfect for my use. So if you're interested, watch till the end and let me set up the module and show you how to set it up. And I've already soldered the pin headers along with the spring antenna that I got with the module, and this I got for about $10 each, so it's not very expensive. In fact, I also bought this E32 LoRa 433 MHz transmitter and receiver module, which has a claimed range of 8 kilometers or so. And I did test this on the APM, but the problem was the data rate. This has a very limited, or I'd say a very slow data rate, and it simply does not cope with the speed that the APM requires. So Mission Planner cannot connect to the APM, and the connection is not very solid. So that's the reason I had to buy this 8C12. This would have been a better choice as well because it has more range. The only downside is the data rate on this is about 20 bytes or so, whereas 8C12 has a data rate of about 1 megabytes per second. So to program the 8C12 module, we will need this FTDI adapter. On the back side, you can see the connection diagram. So to enter the programming state of this module, we have to bridge the set pin and the ground pin together so that we can use the AT commands to set up the module. So let me just connect this to the FTDI adapter. And then we have to connect the RX to the TX and the TX to the RX. And finally, we have to connect the set pin to the ground. Now, if you want, you can solder a wire between the set and the ground connection, or use a wire and then somehow bridge it. But to keep things simple, I'll use my ST-Link device. So I've plugged in a wire on the set connection. I'll plug it to the ground connection on the ST-Link V2 USB device. Plug in the USB cable for the FTDI adapter, and then plug in the cable and the ST-Link device. So the module should be in AT command mode. So to confirm that, first I'll go to Device Manager, and under Ports, I'll double click on the FTDI adapter, which is on COM14 for me, and in the ports setting, set it to 9600 and rest keep it as it is and click on OK. That's because the default baud rate for the 8C12 is 9600. And then I'll open up serial communicator, which I've linked in the description, and in here select the correct COM port on which you have the FTDI connected. For me it's COM14, so I'll select that. Baud rate, make sure to set this to 9600 and rest as it is, and click on open, and it should say connected to port COM14, so which means our FTDI is connected correctly. So then to test if the module is connected properly, click on this space here and type in AT and click on send, and it should reply 80 OK. So which means the module is in 80 command mode and we can adjust the parameters. Also, make sure that this option is set to CR/LF if you have trouble connecting the module. Now, a couple of settings we have to make sure in order to get the telemetry working with APM flight controller. I've also listed the 80 commands for this module in the description. To check the default settings, type in 80 plus RX and click on enter. And you should see the default settings that are pre-assigned on the module. The baud rate by default is 9600. The channel is set to 001, which is 433 megahertz frequency. And the power is set to 20 dBm, which is 100 milliwatts. And the transmitting and receiving mode is set to FU3, which is what we want, because in FU3 mode, the module is operating at the highest performance, and that's what we want. So now I'll make a few changes so that the APM flight controller can accept the 8C12 module. So firstly, we have to adjust the baud rate. For that, I'll type in 80 plus B. And the baud rate has to be 57,600. And press enter. And it should say OK plus B 57,600. So the baud rate has been changed. Similarly, if you want to change the frequency or the channel, you can type in 80 plus C and then any number between 000 to 100. The default is 001, which is the first channel, and the frequency for that first channel is 433 megahertz. And it says OK. Other than the baud rate, you don't have to change anything as such. To confirm the UART mode is FU3. I'll type in 80 plus FU3. And we have OK for that as well. If you want to adjust the transmitting power, type in 80 plus P. And from this data sheet of the module, we can adjust the power level from 1 to 8, 1 being the lowest and 8 being the highest. Since I want the highest power, I'll type in 8, which is at 20 decibels or 100 milliwatts. And that's OK as well. And now if I type in 80 plus RX, we can confirm the settings that we just changed. So the baud rate is 57,600 and the RC channel and the power and the UART mode. So other than this, you don't have to change anything else. So I'll click on close. And similarly, you'll have to configure the other 8C12 module as well. So I've already matched the parameters on this module and I've connected it to the flight controller. So I'm using this telemetry port and I got this telemetry cable in the kit, which I've connected to the module. The only thing that I had to do was swap the ground cable and confirm the RX and the TX wire is correct. In this picture, I have the wiring diagram. And the 8C12 can only work up to 5 volts. If you supply beyond 5 volts, then the module will get damaged. So keep that in mind. So now let's jump to mission planner. Make sure to disconnect the set pin from the ground in order to use the module. Otherwise, it will still be in the 80 command mode. And now I'll plug in the USB cable to the flight controller. And I'll open up mission planner. Click on connect. Remember, this is with the USB cable that I've connected the flight controller, because we still have to assign the baud rate and mission planner for the telemetry option. So once connected, click on configuration and select standard parameters and click on find and type in serial. and you should see serial 0 baud rate and telemetry 1 baud rate. The serial 0 is for the USB cable. Don't change anything over there. Since we are using the telemetry port, we have the option to set the baud rate for that particular port. In here you have to make sure that the baud rate is set to 57,600. If you select beyond this, you won't be able to get the connection working and it won't work. So you have to make sure to set this correctly. After that, very important, click on write parameters. It will say parameters successfully saved. Click on OK and refresh parameters to confirm. Now for reference, if I click on this stats, you can see that with the USB cable we have some data readings about the connection between the flight controller and the computer. So the bytes that are in use and the packets, if any packet is lost, and the link quality and the bytes that are being used up. Now ideally this is what we want with the wireless communication between the module, and that's what we will test as well. I'll disconnect and now I'll remove the USB cable from the flight controller and plug in the battery. For now, to power up the module, I have the FTDI connected, so I'll just connect this to the computer. And now in Mission Planner, I'll select COM to 14 and the baud rate to 57,600 and click on connect. And the parameters are being read. And the parameters have been acquired very quickly as well. If I click on stats, you can see that it's almost very close to the USB connection data. So 11 packets have been lost. Quality is at 99%. We have the bytes and the packets. If I click on flight data and if I move the drone, you should see that even the HUD screen is moving. I even have the battery voltage, the amp and the percent along with the flight mode. So now the data is being transmitted wirelessly between the 8C12 module. Let me see if I can arm the quad from the computer. Let me turn on the transmitter. Now let's try to arm from the computer. And it has armed. Let's disarm. Okay. Now obviously you can use this to change some of the settings on the flight controller wirelessly, but I'll be using this to try the Waypoint mission, and we have to go to the flight data menu. So I will be testing this and I'll post a video of this very soon. Now to eliminate the USB cable or the FTD adapter in order to connect the 8C12 to the computer or mobile, what we can do is we can use a Bluetooth module like this. So the 8C05 which I can use it as a relay between the 8C12 module and the computer. So that way we can access the flight controller settings wirelessly. So for that I'll have to just adjust the baud rate on this module. So very quickly I'll connect this to the FTDI and make the changes, making sure that the RX and TX are connected properly. TX goes to RX and RX goes to TX. So for the 8C05 to enter the AT command, I have to hold the button on it and plug in the USB cable. So the Bluetooth module is now in AT command mode. So let's adjust the baud rate. And once again, in device manager, in COM ports, I'll make sure to adjust the baud rate to 38,400 because this is the default baud rate for the 8C05. So we have to set that, and I'll launch serial communicator, making sure the right COM port is selected and the baud rate is set to 38,400 for the Bluetooth module, and click on open. Type in 80 and it says OK. So the Bluetooth module is also in AT command mode. All I have to do is just adjust the baud rate. So to change the baud rate, I'll type in 80 plus UART equals to 57,600, 0 and 0, and click on enter. And the baud rate is set to 57,600. So that's correct. So once the baud rate is changed on the Bluetooth module, we can disconnect. If you're not sure about the password and the module name, you can check that by entering these AT commands. I'll power cycle this to exit the AT command mode. And now I can connect this Bluetooth module to the 8C12 module. So the RX and the TX from the Bluetooth to the 8C12 has to be connected properly. So the RX from the Bluetooth module will go to the TX on the 8C12, and the TX will go to RX, and then you just have to connect the power cables for both the modules. Now once again, I'll use the ST-Link device. Since the ST-Link has two 5-volt outputs, I can use those. I'll use a power bank and connect the ST-Link device to this. So that way the Bluetooth module and the 8C12 module are powered up. I've already paired the 8C05 Bluetooth module to my laptop and mobile device, so I can connect it readily. For example, in a device manager, in COM port, the Bluetooth COM port for receiving data on my computer is COM13. And I'll set that to 57,600, and I'll launch Mission Planner. I'll power up the quad. And in here I'll select COM13, making sure that the baud rate is correct, which is 57,600, and click on connect. And it's connected. Loading the parameters. Here we have the stats. So that's how you can use a Bluetooth module as a relay between the 8C12 module and your computer. If you want, you can also connect this to a mobile device. So I'll disconnect from the computer. So for example, I'll connect this module to my other mobile device. So I'll go to Bluetooth, click on pair new device, and this is my 8C05 module, which I've named as FlySky FSI6X. I'll type in the pairing password. Once it's paired, I've already installed Mission Planner on this phone, so I'll launch that. On the top right corner, I'll select the Bluetooth module, which is BT FlySky FSI6X, and the baud rate for that. So I have to set this to 57600 because that's the baud rate I've assigned to the module, and then click on connect. And it has connected and the parameters are loading up. So it has connected. Here we have the stats. If I go to setup, optional hardware, motor test, and let's test motor B. So let's try an arm from the mobile phone. So I'll click on arm. It took a while to arm, but it did. Let's disarm. Yes. If you don't intend to fly long distance and if you're not a fan of the Waypoint feature, but you still want to access or change the settings without the USB cable, then what you can do is you can simply connect the Bluetooth module to the APM flight controller on the telemetry port and then connect to your mobile device or laptop over Bluetooth and adjust the settings. I'll cover this in the next video, and it's going to be a very simple video as well. I hope you found this video helpful and informative. If you did, please make sure to like it and subscribe to my channel. Very soon I'll be testing the range of this HC12 transmitter and receiver module and see how it performs. So until then, thanks a lot for watching and stay tuned for more videos.